We are going to dive into the topic how a smartphone works. So, as you can see in the screen, these are the main components of a smartphone. The physical hard drive, where the computational resources, hardware resources, and sensors exist. The operation system, the operating system is the manager, which is going to communicate between the hardware and the software, and the applications which we utilize, like Zomato, Google, Chrome, etc., which are the user facing logic. A smartphone is not a single monolith, but a stack of tightly integrated subsystems. So, what it means that is that a smartphone is not built upon a single system. It is the integration of multiple subsystems which are categorized based on their working. So, we'll first get to know the main components which are going to process everything within the smartphone. Previously, we used to have only two main components, which is CPU and GPU, central processing unit and graphic processing unit. But after the advancements of AI, we also got the third computational resource, which is the NPU or AI accelerator, neural processing unit. Okay, so we'll get to know about each of these computational resources one by one. The first is the CPU. CPU executes the instructions, it handles the logic and operating system tasks like scheduling and the application code. So it is going to take care of all of these tasks. And when it comes to the GPU is completely about UI, graphics, animations, and handling the game interfaces. Completely takes care of the graphics side. So it renders UI, animations, and games, and also handles parallel graphic workloads. NPU, Neural Processing Unit, it runs machine learning models locally for face unlock, camera AI. As we know, the current cameras also have been integrated with AI, so to enhance their capabilities, right? And voice processing. For suppose when we talk to Hello Google, there is also an AI software which is utilizing that currently. So for all these processing, a neural processing unit is utilized or an AI accelerator. Power and state management. Okay, there are two different mainly there are two different types of memories within a smartphone, which is the RAM and the ROM. RAM stands for random access memory. It is the memory where the all the live executions which are happening, live processes which are happening, happens within the memory of the RAM. So it's a temporary working memory, stores running apps and operating system tasks process. More RAM directly enables better multitasking. So if we have a large amount of RAM, then the number of tasks which we can do at a time can increase, right? Because each task will get a good enough amount of memory to execute, which will help based on the proportionality of the RAM. Next is the storage. The storage is called as the ROM, read-only memory. It's a memory where the data gets saved. For suppose there is an output of a process which is happening, so that will be saved in the ROM, right? For suppose when you take a photo with a camera or record a video with the camera with the smart camera of the smartphone, then the output, which is photo or the video, needs to be saved, right? These will be saved within the storage, which is also called as the read-only memory. So it's like a permanent storage, which can save for years. It stores the OS also. Like for each and every phone, we are going to have the operating system, right? So for Android phones, it's the Android operating system, and for Apple phones, it's the iOS. It stores the operating system, the applications which we are downloading, the outputs of the processes which we are running, like photos, videos, voice recordings, and various different types of files like PDFs, PPTs, TXT, etc. Battery and the power management. So, for the smartphone to work, it requires some power source, right? Like how humans eat food and drink water as their power source. The power which smartphones use utilize is electricity, which will be saved within the batteries. The most common battery which is used is a lithium-ion battery, paired with a power IC that regulates the charging and voltage distribution across the board. So it is going to make sure this power IC, this unit is going to make sure that each and every component within the hardware will get the necessary voltage, will get the necessary electricity towards it. So it is going to regulate that. So these are the two main components. One is the battery, and one is the power management unit, which is the power IC. Interfacing with the physical world and global networks. So to interface with the physical world, there needs to be sensors, right? So there are multiple types of interfacing per se. Like for suppose when you walk, the step count gets registered within our phone. That is the movement sensor, which is the accelerometer. And when we rotate our phone, it also gets sensed. That is the gyroscope and the location, where we are. We use the GPS, global positioning system, proximity, proximity sensor. It is used for suppose you want to unlock your phone with your face, then it needs to be at a certain distance from your face, right? That is the proximity sensor, and the ambient light sensor, which adjusts the brightness. We also have the automatic brightness adjustment, right? That works on this ambient light sensor. And we have the connectivity chips, which is going to do multiple works like Wi-Fi chip, Bluetooth chip, NFC, cellular modem, 4G or 5G. Cellular modem is for the signals which we get from the like the 3G signals or 4G signals or 5G signals. Wi-Fi is for the as you know, when we have a Wi-Fi connection to be able to connect to the Wi-Fi, we need the Wi-Fi chip. Bluetooth, if you want to connect your earpods or transfer any files from one phone to another phone, we are going to connect the Bluetooth. And NFC, which is for short range communication, like if you want to make any payments to tap and pay, there for those type of scenarios, we are going to use the NFC. And finally, we have the display controller, which is going to control the screen. The screen which we are interfacing to be able to observe everything which is happening within the phone, which can be the LED or LCD or various different types of screens available, like based on the quality of the screen. These quality of the screen is dependent on the amount of uh, based on the pixel rate, etc. There are various metrics involved in it. This display controller unit, what it actually does is that it pushes the refresh rate uh, from 60 hertz to 120 hertz and above. So that's what we are going to use a display controller for. Walking the silicon and assigning a manager. So we'll get to know about the boot process, like what actually happens when you turn on the smartphone. So we are going to press the button. We are going to hold the power button, and we are going and the the smartphone starts, right. That's This process is called as a booting process. Okay. So this process actually happens within the ROM. Boot ROM runs. This happens within the hardware. Next, we are going to have the bootloader to turn on the operating system and turn on our phone. and the bootloader is going to load the OS kernel. OS kernel, we have the operating system there. First, you need to know what actually an operating system is. Operating system is a system which manages the hardware and the software. It's like a communication medium between the hardware and the software, and it runs multiple tasks like task scheduling, management of the hardware, etc. So the bootloader is going to load the OS kernel, and the kernel is the core part of the operating system. Okay, and OS initializes hardware and UI appears. So this is the total boot process. Power button pressed, boot ROM runs in the hardware, loads bootloader, bootloader loads OS kernel, OS initializes hardware, and the UI appears. UI in the sense the interface which you are seeing. OS manager. So as I have talked about the operating system manages the hardware, the memory, the security, the applications. It acts as the manager for all the different types of resources which are available within the smartphone. Bridging the gap between hardware and user applications. Okay, the after the physical layer, we are going to have the kernel layer. You can look at it from the bottom to the top. First, we'll go with the kernel layer. The kernel, which is a core part of the operating system, handles process scheduling, memory management, and device drivers. Device drivers in the sense like Wi-Fi driver, Bluetooth driver, etc. Hardware abstraction layer. This is the critical bridge between the applications to the hardware because the applications cannot directly to the hardware. We need to require this layer, the hard layer, the hardware abstraction layer, to be able to talk to the hardware. It's like a communication medium between the applications to the hardware. System services. Background utilities like location service, camera service, and notification service. These are the system services which are integrated within the smartphone, which you don't require to download. Like the other apps which we download, these are the inbuilt services which are provided. Next is the application framework. Provides the APIs for apps, UI components, activity lifecycle, permissions. This is the layer which processes the various different types of applications like any games or any browser, etc. Like Brave browser or Opera which you download, YouTube, etc. All the applications uh, run in this layer, which communicates with the bottom layers, which are handled by the operating system. Mobile applications are not always running. So there is a common misconception actually. So we'll get to know how the applications run. We have the foreground. It is where an app is active and visible on the screen. Like when you are utilizing an app, that means utilizing an app, like for suppose when you open Zomato, okay, the app is considered to be active and it is visible on the screen, right? Next is the background. Background in the sense like for suppose when you have that within our tab, but you are using another app. This app, the app which you haven't been using, will be paused, and the code execution is severely limited. Like the amount of executions which are required for the app to get running, it will be limited as it is not running within the foreground. Stop stage. It's a stage where the app is no longer visible to the user. It's a stage where the app is not being used at all. You are not being used by the users. Killed. This is the stage where all the processes regarding that particular app will get killed. So that killed in the sense all the process of that app will be stopped for execution. This is the because the memory within the smartphones are limited and it needs to make room for a new foreground app. which the apps which we are going to open later. Like if you go from one app to another app, then if you are not utilizing that particular app, even if in the background, then it is going to get killed by the operating system. So, operating system manages states. These are the different types of four main different types of states, automatically based on the memory pressure. Like for suppose if the memory is going to be almost finished, then it is going to kill the apps which are of the lowest priority, which are not running. Launching an application and allocating credits. Okay, so we'll get to know what actually happens when we launch an app. When we are first is we are going to tap on the icon, right? When we tap on the app icon, the operating system is going to create the process so that that app can run. And the memory unit is going to allocate the memory, which is the random access memory, and it is going to load the app code. Okay, and there are two main different types of threads. Threads are used for execution within a process. So one is a main thread, which is strictly reserved for the UI rendering. Okay, so that we are able to view what is happening within the app. For that, for the UI rendering, we are going to have the main thread, and we are going to have the background threads, which are running in the background for the backend of the app to be able to run. It is going to handle the networking and heavy work to prevent UI freezing. Okay. Next is the storage integration. Apps rely on local storage to load fast before network data arrives. Okay, the local DB and we are going to have the flat files and the cache. UI rendering pipeline. So how actually an UI is rendered within a smartphone? First will be the app updates layout. Second is the OS calculates the layout map because it is completely based on computations, right? These computations are corresponded to mathematics, mathematical computations. GPU renders frames. As we have talked before, GPU works on graphics processing. As the name mentions, graphical processing unit. And the fourth is the display shows frames. And the number of frames depends on the features of the phone, like how many frames per second it can show. Like there are 30 FPS, 60 FPS, 90 FPS, etc. FPS stands for frames per second. Network flow and push notifications. Apps send requests via API. Okay. And OS network stack, secure HTTPS. It's so these are the main components when what actually happens in the backend of the application. Okay. Secure HTTPS is the medium, like hypertext transfer protocol. Secured hypertext transfer protocol is the protocol through which it communicates with the server. Okay, it's a communication medium within the internet. It is going to send the request to the remote server, and the server sends the payload. It sends the information which has been asked within the API. That's considered as the payload. It routes through cloud service. OS wakes up display in the background, shows notification. So this is how network flow and push notifications happen. The photon to pixel pipeline. Okay, so we are going to know how a camera module within the smartphone works. The first is a raw light, second is the image signal processor, third is the NPU or AI accelerator, fourth is the pixel output. Previously, we didn't have the NPU as a recent advancements for AI. It's more commonly used within the camera module now than a neural processing unit. Raw light. Camera sensor captures raw light data upon explicit voice permission. So when you open the camera and when when the permissions are given to that camera to be able to capture photos and videos. Then, uh, when it has that specific permissions, it is going to capture the raw live data. Okay. Next, we are going to have the processor, which is going to process this data which it received, visual data which it received, which is considered as the image signal processor. It executes real-time noise reduction, HDR balancing, and color correction. These are various different metrics which are required to process a raw light data. And next, we have the NPU, which applies computational photography and AI enhancements, like enhancing the contrast, etc. These are done by the AI generator. Next is the pixel output. Final optimized image is saved to encrypted storage and displayed. So after all the processing happens, it will be saved to the device within the storage or the read-only memory. Isolating applications in secure walled gardens. So as we have talked, we can within a smartphone we open multiple apps at a time, right? So all these apps need to be isolated so that uh, they won't have any communication between them. As they are separate apps, they need to be isolated so that they will have their own specific memory to know. Every app runs in an isolated background, which is called as app sandboxing. It cannot access another application's data or memory space. Okay, so we have explicit permission sets, which is apps are logged out of hardware by default. They must request access. Okay, the apps which we are downloading, you know that when you download the app and when you open the app, it requires the permissions, right? The reason for it is because by default, the operating system doesn't allow any permissions to the applications which we are downloading. We need to give explicit permission to the when we open the application so that that particular application can use the services which it wants to, which it is providing. They must request access to the camera, location, and storage. For suppose if you have downloaded an game and if you want to get the notifications from the game, you need to we are going to have an alert which is popping up in that game, and you need to click on allow so that the OS grants the permission for the app for the game, and it is able to show the notifications. Next is the encryption. Local storage is encrypted at rest, and all modern networks transit is encrypted via HTTP. So what it means is that there needs to be security for the storage, right? So it is going to be encrypted in the sense there will be some mathematical computation behind it, which is going to make sure that the data is not visible so that it cannot be cracked. And that doesn't work only for the local storage. There is also encryption happening with all different types of data, like even the modern network transit, like when we are going to transmit information over the network, over the internet. It is also encrypted via secure HTTPS. Navigating physical limits without active coding. So when these computational resources within the phone, within the device run, it is going to produce heat. Okay, and when the heat exceeds the limit, like for suppose it exceeds 60 degrees Celsius, it is considered as a throttling zone where where the computational resources wouldn't be able to work properly. Okay, here we have three different concepts, which are the performance management. The OS constantly optimizes CPU, battery, and memory usage based on real-time and environmental factors. Okay, these environmental factors can also be how we use and also the temperature which is outside. Those can also affect the system, right? Thermal throttling. Because a phone lacks cooling fans, if the SoC gets too hot, the OS forcibly slows down the CPU to prevent physical damage. As you know, Thermal throttling in the sense if the computational resources exceed the limit. What the operating system does is that it is going to have the health monitor right for the hardware, and if it exceeds the heat limit, then the operating system is going to slow down the CPU to prevent system damage. Back to optimization. Uses CPU scaling, aggressive background app filling, sleep modes, and dark mode to preserve power. So when it comes to smartphones, we have mainly two different types. Like one is the power saving mode, and one is the super power saving mode. When we turn on the power saving mode, the number of processes which are running in the background will be heavily restricted, and also that's not the only way. We can also turn on the dark mode because the number of pixels which are active within the dark mode would be less, so the amount of power which the smartphone requires would also be less. And we have the super power saving mode where we can restrict the number of apps which we are using. We can only use a limited number of apps, which is going to save the power and also the compression resources. Why mobile architecture differs from desktop computing? So there is a lot of difference between the desktop paradigm and the mobile paradigm. Okay, so let's consider multitasking. Desktop has a lot more computational resource when we compare to a mobile phone, right? The reason for it is because desktops are made to be large, which can have a lot more hardware compared to a smartphone, and it can have a lot more computational power. But when it comes to a mobile, it is compact. It is compressed to the size, so it won't have that much computational resources for that much memory. So desktop paradigm is that when it comes to multitasking, it runs two simultaneous background processes indefinitely. It can run multiple background processes at a time. But when it comes to mobiles, smartphones, it prioritizes the app which is running in the foreground and is going to restrict the execution of all the other background processes to save battery. Memory management uses hard drive to swap space when RAM fills up to prevent crashes. Okay, so what it means that is that for suppose when the RAM is almost full out, then the hardware space is going to be utilized so that it so that the crashes are prevented. But when it comes to smartphones, it ruthlessly kills background apps to free RAM. When the RAM is going to be almost done, then it is going to kill all the background apps so that the amount of the RAM will be freed up. So common developer mistake, treating mobile multitasking like desktop multitasking. Those both are completely different because the amount of computational resources which are available is different. So if the developer traces the mobile multitasking the same like desktop multitasking, then it will result in frozen apps and drained batteries. So apps must be built to gracefully save state and die. So what it means is that the apps which are going to be run is going to be based on the foreground app will be given the most priority, and if the RAM is going to be almost done, the background apps will be killed. Their processes will be stopped. A day in the life of a complex request. So we'll get to know about various different types of requests, like what actually happens within that request. Let's consider face unlock. Camera is going to capture the face, and the NPU runs the local AI model. OS matches secure data, and the device unlocks. Okay, so when you capture the face, the NPU is going to run the local AI model, right? And the operating system is going to match with the data, like when we save the face lock with our face, it is going to match. It is going to see if the face is going to match the face which is secured within the operating system, right? It's within the system, within our smartphone. Then if it matches, then the device unlocks. Food delivery app. User open when the user is going to open the app by tapping on the app. The UI loads from the local storage, and the background thread initiates an API call. So there is a main process between within a food delivery app. Next is the integration. OS queries GPS sensor, backend filters restaurants by location, data returns via 5G modem, main thread updates UI flow. So this is the main concept, main thing which happens with this particular example. So this is let's recap what actually we have studied. So the main components within the smartphone are the hardware, which are the computational resources and the sensors. OS, which is the manager, which is going to manage the hardware, applications, and the software, which is the operating system. Next is applications, which as a user logic, which are running in our phone. The apps, these apps can be system applications or the apps which we download. We normally get applications which are pre-downloaded, right? Like the camera, uh, like Chrome, YouTube, etc. It is dependent on the operating system which we have downloaded. We get some pre-built apps, right? And we can also download the apps from the Play Store or App Store too. So these three, the combination of these three subsystems is the smartphone. The end-to-end workflow. When the user taps, they always schedule the process for that app. The app runs the logic. This logic is run within the computation, within the processing units. The hardware executes. The data processes locally or globally, and the UI is updated. So this is what actually happens. And let's get to know about the modern trends like on-device AI, edge computing, and ultra low latency 5G. Previously, we used to have only 4G, right? Now we have 5G, are pushing the architecture to the limits. So this is what smartphones are, and these advancements will improve a lot more in the future.